ground.
Hold the glide.
Near Zurich Airport, a DC-9 plows into the ground 10 kilometers short of the runway.
It was a fatal loss of life. It was a tragedy.
You have impressions and smells that you never forget. It changes you.
Pitch and roll, fine. Flaps, good. No stabilization problems.
Close analysis of the evidence only deepens the mystery.
It was definitely flying too low, but why, we didn't know.
Maybe there's something we can't see.
Could a hidden fault deep inside the airplane have led the two pilots down a deadly path?
That put all the other aircraft in the sky in danger.
Zurich, good evening. Alitalia 404, descending 100. Echo received.
Alitalia 404, Zurich arrival, good evening.
The crew of Alitalia Flight 404 is nearing the end of an evening flight to Zurich, Switzerland.
Alitalia
404, fly heading 325, radar vectors to ILS 14.
Radar vectors to runway 14 on heading 325.
Captain Raffaele Liberti is a senior Alitalia pilot with more than 20 years' experience.
How much is the visibility?
Visibility is 9 kilometers.
First Officer Massimo De Fraia is the pilot flying the plane tonight. He's new to the airline, having joined just last year. Franco Brigante also flew for Alitalia in the 1990s.
At the time, it was one of the safest companies and best trained in the world. I knew the captain very well, the co-pilot a little less.
There are 4 flight attendants and 40 passengers in the cabin.
Thank you.
Several of the passengers are Swiss industrial workers, heading home after a lengthy stretch of work.
Oh, it'll be nice to get back home after all this time away. Let's hope they recognize us.
Typical passengers were employees going back and forth from Switzerland to Italy, especially to Milan.
The plane is a McDonnell Douglas DC-9 that's been flying since 1974.
The DC-9 was one of the mainstays of the industry from the 1960s through the 2000s. It was very, very popular in the US, Western Europe, and around the world, primarily for shorter regional trips.
Even if it wasn't among the more modern planes, it was a good airplane.
Flight 404 left Milan's Linate Airport 25 minutes ago. The flight path takes it almost directly north over the Alps to Zurich's Kloten Airport.
Lufthansa 1873, maintain 240.
At Zurich Air Traffic Control, it's a busy evening.
Swiss 3611, maintain 230.
The airport is one of Europe's main hubs, serving 12 million passengers a year.
Alitalia 404, turn right
heading 340.
Right 340. Alitalia 404.
Alitalia 404 is lining up for its approach to the airport.
You should slow down a bit. The faster you go, the less time you have for landing.
Alitalia 404, reduce to 210 knots.
210 knots, reducing. 404. You see?
Alitalia 404, descend to 4,000, turn right, heading 110. Cleared ILS approach, runway 14.
4,000.
Turn right, heading 110. runway 14.
The pilots are preparing for what's called an ILS, or Instrument Landing System approach.
Instrument landing system is a series of technologies, primarily radio transmitters on the ground, that allows an aircraft to align itself both vertically and horizontally with the runway.
Alitalia 404, reduced to 180 knots.
Reducing 180404. Do you have the glide slope?
It's on 1.
Let's do it on 1.
The crew sets the navigation instruments to pick up the ILS signal from the runway.
Radio unconfirmed.
There's a set of signals which goes out at an angle from the ground that gives them an idea of the glide slope, which is typically around a 3-degree slope.
Gives you one tiny pencil-thin beam that you can fly down that ensures that you're going to stay above the trees and not hit anything below there. And it'll lead you right to the end of the runway.
Alitalia 404, reduced to 160 knots.
Reducing 160.
Capture loc, capture glide path, so we're on the beam.
Flight 404 is third in line on approach. The runway 19 kilometers straight ahead. The pilots can't see it yet, but their navigation instruments show they are locked onto the proper signals. All they need to do now to finalize the approach is intercept a radio beacon known as the outer marker.
The outer marker is something like the last occasion to check whether the ILS is correct.
That tells them as they get closer that they're still right on the money.
Flaps 25.
Flaps 25. The outer marker check is at 1,250 feet, almost 4 miles.
Didn't we pass it? Didn't we pass the outer marker?
No, it hasn't changed yet.
Alitalia 404, speed as convenient. Contact tower 118.1.
118.1, goodbye.
That doesn't make sense to me.
The runway should be just ahead, but the first officer still can't see it. Something's not right.
Go around.
No. Hold the glide. Can you hold it?
Yes, sir.
Lufthansa 1034, reduced to 160 knots. Alitalia 404.
The controller has no idea why Alitalia 404 has suddenly disappeared from radar.
Rabbit 932, established ILS 14.
Rabbit 932, do you see an aircraft ahead of you?
Stand by. No traffic in sight, but there's fire on the ground.
Roger.
It can only mean one thing.
This is air traffic control. We have an emergency.
Swiss and German firefighters rushed to the site of the crash of Alitalia Flight 404, a forested hillside 10 kilometers from Zurich's Kloten Airport.
At first, you could see a glow in the woods, and there was a taste of burning rubber. And when we could finally see the actual crash site, it was horrific.
The plane has cut a swath through the trees, scorching the surrounding area. The scale of the destruction is staggering.
The airplane was completely destroyed. The main goal was to save people.
But as fire crews suppress the flames and comb through charred debris, they can find no one to save. All 46 people aboard the flight are dead.
I was very upset because it was a loss of someone close.
You have images that you have to deal with. You have impressions and smells that you never forget. It changes you.
With the wreckage still smoldering, an investigation into what happened is already underway. Hans-Peter Graf is with Switzerland's Air Accident Investigation Bureau, or AAIB.
First thought is, well, bad news. It's going to be a big and long investigation. I had to get a first impression of what had actually happened that night. So I went straight to Air Traffic Control Center in Zurich.
Hello. Good evening.
Good evening.
Do you have some time to speak?
Graf meets with the last person who spoke with the Alitalia crew.
What can you tell me about Flight 404?
I hope to learn if the crew had issued an emergency beforehand, if there was anything unusual about the airplane.
It was routine. They were making an ILS approach, as usual. Huh. They never reported any problems.
Can you replay the radar track?
Yes, of course.
Graf knows that most control centers keep recordings of all recent radar tracks.
I had a closer look at the radar screen itself. I saw the airplane symbol, AZ404, together with the altitude reading on the screen.
Well, they may not have reported a problem, but they sure had one. Look at that glide slope.
Graf discovers that more than 5 minutes before the crash, Flight 404 was already too low and descending lower.
I noticed that the airplane was flying 1,200 feet below the actual flight path.
The proper glide slope would have taken the DC-9 on a gradual descent right to the foot of the runway. Instead, the plane flew an almost parallel path, more than 1,000 feet lower, right into the side of a small mountain.
You didn't notice their altitude?
What? I was juggling 6 flights. All the 404 calls were normal. They said they were on glide.
That particular controller would assumed if they were reporting they were lined up with the runway and that they were on the glide path, that they were safely above any terrain.
And your minimum safe altitude warning system didn't sound?
We don't have one installed as of yet.
Unfortunately, at the time, they didn't have the minimum safe altitude warning system in place in Zurich. In the U.S., it had already been in place for 10 years.
You said they were doing an ILS approach.
Mm-hmm.
Then we don't have a choice. Shut the system down immediately. We can't risk another flight.
Graf worries the runway guidance system may be malfunctioning. A full test of the system will cause major disruptions for Zurich Airport, but it has to be done.
If the ground transmitter was malfunctioning, that put all the other aircraft in the sky in danger. So they have to shut it down until they have it checked out by electronic technicians.
It could take a day or more to get results. But if the testing reveals a fault with the ILS, it could explain why Alitalia Flight 404 ended in tragedy. Daylight reveals a 300-meter-long scar through a hillside forest northwest of Zurich, where Alitalia 404 crashed hours earlier. Joining the investigation is Bob Benson of the U.S. National Transportation Safety Board.
Because the aircraft was manufactured in the United States, our role is really to assist the Swiss government in determining what happened.
It's a lot of fire damage. It's gonna make IDing parts a real chore.
The thing that stuck out was the amount of destruction. The only truly recognizable things were the engines and the landing gear. but the rest of it was pretty well burnt up.
Let's see that map again.
Investigators wonder what the mangled terrain can tell them about the plane's last moments.
It looked to us like the aircraft had struck the trees in a bit of a level attitude, although parts of the right wing had been sheared off by the trees, and that caused a more lift to occur on the left side of the aircraft, causing the aircraft to roll. So the eventual impact was nearly inverted.
Hello, Benson.
Benson gets word on Zurich Airport's instrument landing system.
That's for certain? Okay.
Overnight testing has revealed that the guidance technology is in perfect working order.
Captured loc, captured glide paths, so we're on the beam.
It means the ILS was sending the proper signal throughout Flight 404's descent to the airport.
The ILS is fine. So whatever brought that plane down, the evidence has got to be here somewhere.
That led us to believe that perhaps there was a problem on board the aircraft rather than on the ground.
More answers about the mysterious crash might soon be close at hand. The team has recovered both of the plane's black boxes. But they won't know if the data they need has survived the crash until they get the recorders to a lab for analysis.
So, they were cleared for runway 14. Looks like they're on the right heading. They're way too low. It's like they don't even know the hill's there. Wonder how well the pilots knew the route.
Searching for answers, investigators look into the pilot's work records. They discover that besides being a senior Alitalia pilot, the captain was also a former military airman.
We learned that the captain had over 10,000 flying hours.
Zurich, good evening. Alitalia 404, descending 100. Echo received.
What's more, the Milan to Zurich route was nothing new to him.
The captain, who has flown this route many times in his career, was pretty familiar with it.
They learned that the 28-year-old first officer was far less experienced, but his record is spotless, and he'd also landed at Zurich before.
Both pilots had flown this route many times before in the same cockpit sometimes, so they were familiar with what the approach should look like.
Across Zurich and throughout Europe, news of the crash has left people rattled. The quiet city, best known for its banking sector, hasn't seen a major air disaster in almost 20 years.
There was such a tragedy. It was an all-fatal loss of life, and so it was reported in the media extensively.
The media attention puts mounting pressure on investigators.
Is this the flight data?
Finally, they have some good news. Information from both the flight data recorder and the cockpit voice recorder has survived.
We should get this up on the projector.
But will it provide the answers investigators need?
Was there an aircraft malfunction of some sort, an instrument failure, a flight crew problem? Those are the immediate things that you zero in on.
Well, there's not a lot of parameters, but it should tell us something.
Investigators begin with the flight data, looking for any sign of a mechanical problem on board.
Thrust is good.
Although the thing was reasonably ancient compared to the modern ones, it only had 10 parameters. 2 of those parameters were engine pressure ratio, which means how much thrust the engines were putting out. And they showed us that the engines were operating normally up until the time of impact.
Pitch and roll, fine. Flaps, good.
Yep.
No stabilization problems. Everything seems normal from a mechanical standpoint.
Even the glide is smooth and straight. It's just all over 1,000 feet too low. I don't get it.
The data doesn't reveal any mechanical failure that can explain the crash. It only confirms the mysterious glide path recorded by air traffic control radar.
On the FDR data, we could not find any technical issues at all. The airplane performed as per design. It was definitely flying too low, but why, we didn't know.
We set up the playback machine. We need to hear what was going on in that cockpit.
Trying to understand why a well-trained Alitalia crew flew their DC-9 into the ground kilometers short of the runway, investigators now turn to the cockpit recording.
Something was going wrong with the perceptions of the crew, perhaps the aircraft itself, to cause it to be almost 1,000 feet, maybe a little bit more, below where it should have been on the approach. So that became a focus.
But as soon as they start listening to the recording, they know they have a problem.
There was a lot of noise, and it was, first of all, difficult to understand.
Sounds like they weren't using their headsets for some reason.
You should slow down.
The flight crew weren't using boom microphones. They were just talking into one single microphone located in the middle of the instrument panel.
The faster you go, the less time you have to land.
So this led to some of the words not being understood by the accident investigators.
Send it back to the lab. We won't be able to get anything off there.
It's a disappointing setback. Investigators can only hope lab technicians can find a way to filter out the noise and produce an audible recording.
So it was very difficult for the investigators to create a true transcript.
In a facility at Zurich Airport, investigators survey wreckage recovered from Alitalia Flight 404. They're looking for any clue that might help explain why the DC-9 flew for more than 5 minutes on a fatally low glide path before plowing into a hillside.
You know, I'm surprised there are planes that still have this altimeter. They're ancient. What if they misread their altitude?
The DC-9's cockpit was equipped with what's known as a drum pointer altimeter.
The drum pointer altimeter is known to be prone to be misread.
You have to look at the drum, and then you have to look at the needle. And it's almost like an analog watch versus a digital watch.
Unlike a modern digital altimeter, the drum pointer design can only be read in 2 steps. Feet in thousands is indicated on a drum, like an odometer in a car. Feet in hundreds is indicated by a pointer that moves around a scale like a clock face. The problem with the design is as it moves, the pointer can sometimes obstruct the pilot's view of the numbers on the drum.
If that needle happened to be obscuring part of the odometer that showed the thousands of feet, there could be some confusion as to whether it was one particular altitude or maybe 1,000 feet away from that. So the potential for confusion existed.
The industry has been phasing out the notoriously confusing instrument for years, but it's still found on older planes like DC-9s from the mid-70s. At this stage in the investigation, the team has no way of knowing if the pilots misread the instrument.
They did misread it. That could explain why they were so low on approach. But the GPWS would have warned them.
The Ground Proximity Warning System, or GPWS, is an onboard technology designed to help pilots avoid terrain. The system bounces radio waves off the ground below to measure altitude and sounds a cockpit warning if the plane gets too low.
And there's no mistaking that alarm.
Investigators know the Alitalia DC-9 was equipped with a GPWS. But did the pilots get a warning before the fatal impact?
We really need that CVR. Hey.
Hey.
All right, this is the proper glide slope for runway 14.
Great. I've got the transcript for the enhanced recording.
They hope to finally get some answers from the cockpit recording, now cleaned up by audio technicians and ready for playback.
The picture that was given by the full transcript is more than enough to get a very good idea of what the sequence of events was in the cockpit.
Okay.
Can we do a radio approach?
Yes.
We're at just over 4,000 feet right here, which is well below the glide slope.
Okay, but they need to level off to capture the glide, but they kept ascending.
On 1.
Let's do it on 1.
Radio 1 confirmed.
Sounds like they're just on radio 1.
ILS transmitters send radio signals to 2 navigational receivers in the cockpit, Nav Radio 1 and Nav Radio 2. The pilots can use either one to guide the plane. Investigators now know the crew selected Nav Radio 1, but they're still hoping to discover something about the unusual low glide slope and about the GPWS.
Alitalia 404 reduced to 160 knots.
Reducing 160. Capture glide path. So we're on the beam.
Did you stop it there? On the beam? You're well below the glide slope there.
They are more than 1,000 feet below it.
So why is the captain saying then that he captured it?
What they're hearing from the cockpit only deepens the mystery. Investigators know that right in front of both pilots is an instrument that should be showing their exact glide slope position. It's called a glide slope indicator.
There are visual cues, specific systems that are in place that give a pilot an idea whether or not they're too high or too low on the glide slope.
Did they misread the altimeter and the glide slope? I mean, that doesn't seem possible.
Let's keep listening for the GPWS.
Okay.
Flaps 25.
Flaps 25. The outer marker check is at 1,250 feet, almost 4 miles.
Didn't we pass it? Didn't we pass the outer marker?
No. No, it hasn't changed yet.
Something in that cockpit is confusing these pilots.
Alitalia 404, speed as convenient. Contact tower 118.1.
118.1. Goodbye.
That doesn't make sense to me.
Go around. No, no, no. Hold the glide.
The CVR had the first officer attempting to go around and then being countermanded by the captain. There was a lot of confusion there.
Can you hold it?
Yes, sir.
Investigators are stunned both by what they've heard and by what they haven't heard.
No ground proximity warnings at all.
The fact that the aircrew didn't get a warning from the ground proximity warning system was a surprise to us.
And the captain called off a go-around.
They now face more questions than ever. How could 2 professional pilots both misread their glide slope indicators? Why did the plane's ground proximity warning not sound?
Go around.
And why did the captain call off the one maneuver that might have saved his plane and his passengers?
This one looks pretty beat up too.
Investigators examine a pair of flight instruments recovered from the cockpit of Alitalia 404. The heading indicators, known as HSIs. They hope the damaged instruments can confirm whether or not the pilots misread their glide slope on approach to Zurich.
They recovered the HSI from the wreckage. We wanted to know what was the indication of the glide slope.
Okay, so that mark there, is that the same as on the first one?
They closely examine a small arrow on the glide slope indicator, situated on the right side of each HSI. It's the instrument that tells the pilots if they're flying too high or too low.
We found what we call slap marks, which means the indicator, as it was being destroyed, the needles on the indicators slapped against the background. So at the time of impact, you could determine what that instrument was showing you.
It did have markings on it showing that they were on glide slope.
So they were both indicating on glide.
It's a major discovery. It means that both indicators were on the glide slope, and the pilots didn't misread them.
Captured loc, captured glide path, so we're on the beam.
The captain announced capture because his instrument was showing him he was on the proper descent path, even though he was actually more than 1,000 feet below it.
They got what's called a false glide slope.
And that kind of led us to wonder how that could occur.
The team now needs to understand why critical cockpit instruments were displaying the wrong glide slope. With help from Alitalia, they begin examining the onboard source of that information, the #1 navigation receiver. Did the unit have some kind of defect that caused it to send a faulty signal?
I couldn't understand why can the autopilot fly a faulty glide path? Why the pilots don't get warned about that? There must be something totally wrong with this receiver.
I don't see any corrosion. All the internal components seem to be in the right place. No obvious defects. Maybe it's something that we can't see, like a short circuit.
Well, we had a very good idea that the NAV1 receiver was putting out false information, but we couldn't directly test it because of damage to the device during the accident sequence. So the Swiss investigators decided to do some testing.
Investigators start by deliberately shorting out a NAV1 receiver and then testing it in a flight simulator to see what happens.
Okay, it should be in the menu. I pre-programmed the route as 404 approach.
Simulation tests are important during an accident investigation because what you're trying to do is recreate the scenario and circumstances that led up to the accident.
Then they simulate the flight path of Alitalia 404.
We're 15 miles out, 1,200 feet below glide. Stand by.
Groff wants to see if he can reproduce the same false glide path that deceived the Alitalia crew.
Switch to radio 1. There it is.
A false glide indication on the display.
And no warning flags.
Groff is stunned to see that the short-circuited receiver defaults to the on-glide position, and that there's no warning about the malfunction.
Typically, if the signals are not correct, there's some sort of warning given in the instrument itself. There was no warning.
I was really surprised that somebody could design a piece of equipment without warning the pilots if there's something wrong with it.
It was a kind of an aha moment.
Captured loc, captured glide path, so we're on the beam.
There is now no doubt that a short circuit in the NAV1 receiver caused the deadly glide slope display malfunction. Did it also somehow disable the potentially life-saving ground proximity warning?
Keep going.
That's what Groff wants to know next.
30 seconds from impact.
The simulation soon gives him an answer.
Nothing. It should have sounded by now.
The plane's GPWS never sounds a warning.
And it turns out that if the navigation radios aren't putting out a good signal to the rest of the aircraft, the GPWS just doesn't work.
The GPWS finding leads to another disturbing question.
That doesn't make sense to me.
Would the crew have been able to save their plane and 40 passengers?
Go around.
No. Hold the glide.
If the captain had initiated a go-around when his first officer called for it.
Okay, so no hesitation when I give the order, okay? We're almost there. 5, 4, 3, 2, 1. Go around.
Landing safely. Those poor bastards.
Had the captain not intervened, they would have made it.
The aircraft would have passed over the top of the mountain without striking it. Not by much, you know, a couple hundred feet perhaps.
It's a heartbreaking discovery, one that motivates investigators to try to understand why the fatal decision was made. Why did a seasoned pilot overrule his first officer and miss his last chance to avoid disaster?
Let's take it from earlier in the flight.
For more insight into what the captain may have been thinking, they return to the cockpit voice recording.
How is it approaching? Approaching, turning left to Schaffhausen.
They listen from earlier in the approach to try to get a sense of how well the pilots were working together.
I told you not to go on that beacon.
Well, it was a crew that had a very experienced fellow in the left seat and a very inexperienced fellow in the right seat, and that always causes a bit of a consternation at times during a flight.
Go to the left. You see? You had moved.
What emerges is troubling. The captain seems constantly dissatisfied with his first officer.
It's compulsory to go there.
There seemed to be some sort of mentor-student relationship, the first officer being admonished at some points by the captain.
You should slow down a bit. The faster you go, the less time you have for landing.
Alitalia 404, reduced to 210 knots.
210 knots, reducing. 404. You see?
My impression is that the captain didn't trust the co-pilot's abilities because he already showed that he wasn't very sure what he was doing.
Not exactly an ideal working relationship. Questo comandante aveva un carattere un po'...
The captain was a bit tough,
E il pilota era...
and the co-pilot was a bit weak. So let's say that the absence of crew coordination definitely influenced the flight.
Assolutamente la cosa.
This doesn't make sense to me.
It seems that when the critical moment came, and the captain had only a split second to decide.
Go around.
No. Hold the glide.
His opinion of the younger pilot may have colored his decision.
When the first officer attempted the go-around, the captain, at that instant, didn't trust him to make a good decision.
If there had been a bit more trust between them, who knows?
Investigators now understand the human factors that were at play. But the technical failure at the heart of the accident needs further examination. Other planes could be at risk. Investigators need to learn more about the DC-9's design.
Thanks for coming right away.
They want to know why the Alitalia crew were not warned when one of their nav radios failed.
We needed to work together with the manufacturer of the airplane, McDonnell Douglas.
So this is the system they use for Nav-1.
It's an older model, what's known as an unmonitored receiver.
Investigators learned that the receiver in question is a King KNR 6030. Unlike newer models, the King receiver doesn't monitor the signal it sends to the HSI. This means it can't warn pilots if the signal becomes interrupted. What's more, in the event of a short circuit, the glide slope indicator will display a centered or on-glide position.
This receiver should have been banned from any airplanes. It should never have been possible to install them. That is my opinion.
So the pilots had no way to know that it had malfunctioned.
Well, there would be other clues in the cockpit.
Unfortunately, there are devices within the cockpit that could have given them an indication of something going wrong. They had a standby altimeter that wasn't affected by this navigation problem at all.
Why didn't you warn the airlines?
We did. We even had a seminar to inform pilots. There were at least a couple of the Alitalia guys there.
Investigators are surprised to learn that 6 years earlier, McDonnell Douglas sent a letter describing the problem to all DC-9 operators.
Whenever you possibly can, you remove the hazard. That's the first rule. If you can't do that, the second rule is you warn the person about the hazard. That's what they did in this case.
So it looks like the airline really dropped the ball.
One can't rely on pilots overhearing something in a conference and then overhearing it in the break room, and they implement changes. That's not how it's done. This is a very organized, very procedures-based world where learning has to go through a process.
For some reason, that information never drifted down to the line crew member level. We were pretty convinced that the accident crew members had no idea this false reading could exist.
Investigators now understand the sequence of events that doomed Alitalia 404. It starts with an aging DC-9, carrying 40 passengers, 4 flight attendants, 2 pilots, and a hidden danger.
Do you have the glide slope?
A flaw in the navigation system.
On 1. Let's do it on 1.
Radio unconfirmed.
With this receiver, the best pilot in the world would be at risk.
It would fool anybody.
On approach to Zurich, Flight 404 descends below its intended glide path.
Alitalia 404, descend to 4,000, turn right, heading 110.
The busy air traffic controller fails to notice. The pilots also don't notice, perhaps because of a notoriously confusing altimeter.
Capture glide path so we're on the beam.
But certainly due to a false glide slope indication.
Radio 1 had a non-glide slope indication telling him, okay, we are fine, we are on the correct flight path to the runway.
A disabled GPWS keeps them unaware of the danger until...
Go around.
No. Hold the glide.
The captain's lack of trust in his young first officer seals their fate.
To pin the blame on any one of them, the pilot's role, the air traffic controller's role, the manufacturer of the technology, their role is unfair. This was a multiple input event.
In its final report, the Swiss Air Accident Investigation Board calls for the prompt removal from service of all unmonitored radio receivers.
If there's any doubt about the functioning of a piece of equipment that has to ensure a safe landing of an airplane, it has no place in the airplane any longer.
They also recommend that airlines give first officers more authority in critical flight situations.
After the accident, the procedure was changed so that if the co-pilot sees something wrong and calls for a go-around, and the captain doesn't execute it, he's authorized to do it by himself.
The accident brought important improvements to Zurich Airport as well.
It was after that that Zurich installed the minimum safe altitude warning system in its ATC facility. And so, unfortunately, it took that tragedy to happen, but, you know, at least some positive things resulted from it.
We learn from every accident. Even though they're tragic events, frankly, some good comes out of every single one of them. And the recommendations that came out of this accident have led to an aviation system today that is very, very safe.